What are the various kinds of tests performed on cement? To ensure the quality of cement is up to standard, there are various types of cement tests. These tests can be categorized in field testing of cement and laboratory testing of cement. The field testing of cement include the date of manufacturing of cement. The date of manufacturing of cement should not be more than 3 months old. If it is more than 3 months old, the cement is rejected. The color of cement. The color of cement should be uniform and it should be a typical grey color with a light greenish shade. Hard lumps in cement. The cement should be free from hard lumps. Such lumps are formed by the absorption of moisture from the atmosphere. And if the cement has already absorbed the moisture, it means that the cement has lost considerable amount of strength. Temperature inside the cement bag. If a hand is plunged into a bag of cement, it should give cool feeling. If hydration reaction takes place, the cement will feel warm. Smoothness test. When cement is touched or rubbed in between fingers, it should give a smooth feeling. And if it feels rough, it means the sand is added into the cement. Water sinking test. If a small quantity of cement is thrown into a bucket full of water, it should float for some time before it finally sinks into the water. The smell of cement paste. A thin paste of cement with water should feel sticky between the fingers. And if the cement contains too much clay and silt as an adulterant, it will give earthly smell. That is the smell of soil. Glass plate test. A thick paste of cement with water is made on a piece of glass plate and kept under water for 24 hours. The cement paste should set and it should not crack. Block test. A block of 25 mm x 25 mm x 200 mm is made. That is, the width and the height of the block is 25 mm and the length is 200 mm. The block is then immersed in water for 3 hours for curing. After removing, it is supported 150 mm apart and a weight of 15 kg is placed over it. The cement block should not fail under these conditions. Laboratory testing of cement. The various laboratory tests that are done are fineness test, consistency test, setting time test, strength test of cement, soundness test, heat of hydration test. First one we have is fineness test of cement. The fineness of cement is a measure of particle size. The fineness of cement tells us about the size of cement particle. It is denoted as specific surface area of cement. The specific surface area is area of cement per unit weight of cement. This test is done by sieving the cement sample through a standard IS sieve. The fineness of cement is very important since it controls or since it influences the rate of hydration of cement and the rate of evolution of heat. The fineness of cement is determined using IS sieve number 9, that is 90 micron sieve, and the IS code used for this purpose is IS 4031 Part 1 1996. The standard value of fineness of cement should have fineness less than 10%, or the fineness should not be more than 10% as per Indian recommendation. What is the procedure for finding fineness of cement? First step is to check for the lumps present in cement. There should not be any lumps in the cement. Take 100 gram of cement and note the weight as W1. Put the 100 gram of cement in the IS sieve number 9 and close it with the lid and put it in sieve shaking machine. Shake after shaking for 2 minutes. The weight of the residue retained on the 90 micron sieve is noted as W2. Here W2. After that we calculate the percentage of weight of cement retained on sieve. The formula that is used for the fineness of cement is this: W2 divided by W1 whole multiplied by 100. This formula gives us the fineness of cement. The next test we have is standard consistency cement. The standard consistency cement is very important since it is required to find out the initial setting time, final setting time, soundness and strength of cement. The consistency of cement test is performed to determine the amount of water content that is to be added in cement to attain standard consistency. The IS code that is used for the purpose is IS 4031 Part 4 1988, and the apparatus used is YCAT apparatus. This here shows the YCAT apparatus. This is the mold, this is the needle, the C needle, this is the scale, and this is the weight. The standard or the normal consistency for ordinary Portland cement varies between 25 to 35%. That is 25 to 35% of water by weight of cement is required for standard consistency of cement. The apparatus that is required is YCAT apparatus, balance to find the weight, gauging trowel and stopwatch. Take 400 gram of cement. After that we assume the standard consistency of water as 23%. We mix the paste for 3 to 5 minutes. This time taken is called gauging time. Now fill the paste in the YCAT mold. This is the YCAT mold. The paste is filled completely up to this part. Now fill the paste in the Vicate mold correctly and the excessive paste should be removed. Then place the Vicate mold on the glass plate here, and see that the plunger should touch the surface of Vicate mold gently. The needle it should be directly above the surface of the mold. It should touch slightly the surface of the mold. After that, the plunger is released and allowed to sink into the test mold. Note down the penetration of the plunger from the bottom of the mold indicated on the scale. Here is the scale. Repeat the same experiment by adding different percentage of water, so that it should be about 5 to 7 mm from the bottom of the mold, or it should sink about 33 to 35%, 33 to 35 mm from the top. Initial and final setting time of cement. During construction, when we are dealing with cement paste, cement mortar, or concrete, certain time is required for mixing, transporting, placing, and compacting of cement. During this time, the cement should be in the plastic condition. The time interval for which the mixing, transporting, placing, compacting is done is called initial setting time. After finishing is done, the cement should set quickly. Initial setting time of cement. It is the time elapsed between the moment water is added to the moment the cement paste starts losing its plasticity. And the final setting time of cement is the moment the water is added to the cement to the moment the paste starts completely lose its plasticity and attains certain firmness to resist certain pressure. The apparatus that is used is Vicate apparatus. And the IS code that is used is IS 4031 1988. As per standard, the initial setting time of cement should be a minimum of 30 minutes for OPC, and the final setting time should be 600 minutes or 10 hours. What is the procedure for finding the initial and final setting time? First, we take 500 gram of cement paste with 0.85 times standard consistency of water and make a paste. The moment the water is added to the cement, we start the stopwatch and note down the time. The paste should be mixed for 3 to 5 minutes. The temperature for the water and the room at which the test is performed should be 27 plus minus 2 degrees Celsius. For initial setting time, after we place the paste in the Vicate mold, the needle is gently lowered to bring it in contact with the surface. That is, here the needle is gently lowered so that it is in contact with the top of the surface. After that, we allow it to penetrate into the Test block. In the beginning, the needle will completely pierce and it will reach to the bottom of the mold. After certain time, when the plate starts losing its plasticity, the needle may penetrate only to the depth of 33 to 35 mm from top. That is about this much. At the beginning it was penetrating up to this length, but after a certain time it will only penetrate up to this depth. That is 33 to 35 mm from the top. This is top. We note the time from the stopwatch. How much time it requires so that it only penetrate up to 33 to 35 mm from top. This is the YCAT apparatus that is used, and this is the release pin to release the needle. The indicator, that is the scale, which indicates how much the needle has penetrated into the mold. This is the front view, and this is the non-porous plate. This is the cap, the movable rod that puts the weight on the needle. The area of the needle is 1 mm square. This section is used for final setting time. This needle, the C-type needle, is not used for final setting time. The C-type needle is used for initial setting time, and the G-type needle is used for final setting time. The G-type needle consists of an annular ring. This shows the circular ring around the needle, and it is only projecting about 0.5 mm out of the annular ring. For final setting time, we replace the needle with the circular attachment, that is this circular attachment. The cement should be considered as finally set when, upon lowering the attachment, gently cover the surface of the test block. The center needle makes an impression while the circular cutting edge of the attachment fails to do so. When you lower this attachment on the surface of the mold, only this needle makes an impression on the cement paste, but this circular attachment does not make an impression, is called final setting time. The paste has attained such hardness that the center needle does not pierce through the paste more than 0.5 mm. Next test we have compressive strength test of cement. The compressive strength test of the cement is the most important property of cement. The compressive strength is the capacity of a material or a structure to resist or withstand under compression. Here there is the material which is subjected to compressive forces. When two forces acting on the material toward each other, it is called compressive forces or compressive stress. The strength of the material is determined by the ability of the material to resist such forces. There should not be any cracks or fissure in the material. The machine that is used for the compressive strength test is compressive testing machine. This here is the picture of a digital compressive testing machine. The procedure for finding the strength is we take 500 gram of standard sand. The standard sand is Ennor sand. E double N O R E. Ennor sand. 185 gram of cement. The ratio of cement sand is 1 is to 3. We mix them and the water is added. The water is P by 4 plus 3% of combined weight of cement plus sand, where P is the standard consistency of cement that we have found before. The time of mixing should be less than 3 minutes, should not be less than 3 minutes, and also immediately after mixing, the mortar is filled with the molds of size 70.6 mm or 7.06 centimeter. Thus, cross-section area of the mold is 50 square centimeter, or the face area of the mold is 50 square centimeter. We compact the mold either in the vibratory machine or by hand equipment. Keep the mold at a temperature of 27 plus minus 2 degrees Celsius and 90% relative humidity for 24 hours. After 24 hours, the molds are removed and the cubes are kept immersed in fresh water until testing. Test 3 cubes, one at 7 day, other at 14 day, and another at 28th day. The loading must be applied axially on specimen without any shock and increased at the rate of 35 Newton per mm square per minute till the specimen collapses. Due to the constant application of load on the face of the cube, the mortar cube starts cracking and fails at a point. Note down the reading from the compressive testing machine. The next test we have soundness test of cement by Lee-Chetlier's method. The ability of the cement to retain its volume after it gets hardened is known as soundness of cement, or it is also called as the ability to resist the volume change after hardening. The soundness of cement is due to the presence of excess of lime. Since lime is used in the preparation of cement, if the lime is in excess quantity, it will make the cement unsound. Magnesium or calcium sulfate, that is gypsum, may also make the cement unsound. The apparatus used for the soundness test is Lee-Chetlier's mold, two glass plates, and a weight. These are common. Lee-Chetelier apparatus consists of a split cylinder, that is the Lee-Chetlier's mold, weight, and glass plates. Procedure of the test. Before conducting the test, the mold and the glass plates should be applied a thin layer of oil so that the cement does not stick to the surface of the mold. Take 200 gram of cement and add a water of 0.78 times standard consistency. After mixing, the cement paste is placed into the mold and The mold is covered by the glass plates from both sides. Here it shows the cement mold and the glass plates that are covering the mold from both sides. Submerge this whole assembly into the water for 24 hours. After 24 hours, we remove the whole assembly from the water and measure the distance between mold edges. That is this difference from this point to this point. This length is measured as L1. After that, we submerge the whole mold again. After that, this whole mold is placed into the water again and it is heated so that the water reaches up to the temperature of boiling point. After that, it is allowed to cool down and this difference is again measured after boiling. After measuring the distance, we find that this distance has increased due to expansion of the cement or increase in the volume of cement. The soundness of test should be L2 minus L1. L2 is the final length, L2 minus L1. The L2 minus L1 should not be more than 10 mm per OPC, rapid hardening cement, low heat cement, PPC and high alumina cement. Next we have heat of hydration test. During the curing of concrete, hydrothermal reaction takes place resulting in the production of heat because of chemical reactions. Sometimes the heat is so much great that it may cause the temperature of the concrete to increase by 50 degrees Celsius, which could be harmful for the concrete in mass concreting. The heat of hydration test is generally carried out for low heat cement. Since it is used for mass concreting works, the test is carried out using a calorimeter. This here is the calorimeter which is used for the heat of hydration test. The IS code is IS 4031-1968 for testing heat of hydration of cement. It has been standardized that the low heat cement should not generate the heat of 65 calories per gram of cement in 7 days and 75 calories in 28 days. The heat should be less than 65 calories for 7 days and less than 75 calories for 28 days. That's it.